Today we are going to make a Kaggle project and participate in the competition and submit our trained model. So let's first begin by going to kaggle.com and to the competitions. We are going to do this Titanic problem, which is here getting started, and scroll down to the Titanic problem. This is the easiest project you can which is used to get your hands dirty in the data science field. Basically it's we have to predict whether the passenger survived or not based on the metadata that they have provided, such as age, fare, whether they have family on board, where they embarked, etc. You can read the overview and download the data from here. Download all, and let's get started. As you can see, I've already downloaded the project and created a IPYNB. Let's get started. We will first import the necessary libraries. These are the libraries that we are going to need here. Now let's load the data. Let's view the data now. So the data contains passenger ID survived, passenger class. I'm guessing it's first class, third class, and second class. Looks like it. The name, the sex. SIBSP means number of siblings and spouses, and PR means number of parents, children's. Yeah, so rest are pretty self-explanatory. Let's see the shape of the data. Okay, so 891 examples and 12 columns, and in the test data there are 418 columns and 418 examples and 11 columns. So I'm guessing survived column is not in the test column, which makes sense. We have to predict it. So let's now handle the missing values, if there are any in this data. To see the missing values, we are going to use the function called isNA and its sum. Let's see. Train data dot isNA and sum. So there are 177 missing in age and 687 in cabin. 687 out of 891. I'm guessing we have to drop this table. Also, it does not provide any significant information which is used to predict whether the passenger survived or not. So I'm going to drop this in the engineering features section of the video. Let's see the test data. So in the test data there are 86 missing and 1 fare and 327 cabin. Yes, so cabin is going to be dropped. Let me just write this properly. So let's engineer the new features. Define engineer features. We are going to make a copy of the data frame so that we do not lose the original one. Now we are going to drop cabin, ticket, and name. So now we are going to calculate the average, the median age, and we are going to fill the NA spots with the median age. So average age is equal to df age dot df. Now we are going to assign average age to the age column. Same for fair and embark. For embark, we are going to make the mode. I'm going to use the mode. Okay, this should run. Yep. Now we are going to engineer two new columns called family size and is solo. So family size is equal to number of siblings and spouses plus parents and children. So df sib plus df dr plus 1 for self, and its solo is df of family size. Df family size equals 1. Then the person is solo. This is going to return true or false value. So as type int. Yep, not return. Okay. Now we are going to make two new variables and save the engineer features into them. Key error. Let's see. Drop cabin. Acha. So we have to drop ticket. Yep. Same for the test. Let's see both. Okay. So 891 rows, 11 columns, and test 481 rows, 10 columns. Okay. Now that we handled the missing values, we are going to combine the features and create a combined table, and then we are going to use one-hot encoding to convert text data into integer value for the model. as the model understands the integer value rather than the text data more accurately. So combined is equal to so combined is equal to video concat train FE at combined columns and test FE at combined column. Let's see combined shape. Okay, so the both examples have been combined and created 1309 examples. Now we are going to do one hot encoding. So combined encoding is equal to pd.get dummies combined columns for sex and embark because both of them are not in integer values, and we are going to drop the first to reduce the redundancy and as type int. Let's see. The text data have been vanished and the sex is only reduced to sex male. If the passenger is male, it is 1. If they are female, it is 0. Similarly for embark Q and embark test. Now we are going to split the data again using the split operators. And now we are going to load the model and train the model. Master. Let's get the method of the model. Now let's write that. Let's write the model. See. So model is 80.5% accurate. It's quite a good model. Now let's create a submission to submit. This has created a submission CSV. The values. Now we are going to submit it in Kaggle. Submit prediction. Submit. Our model is 76% accurate. Yeah, let's go to the leaderboard and jump to our position. Currently 10,008. Yes. Thank you for watching and subscribe for more ML content.